The length of the fence of a trapezium shaped field is 120 meter. Find the area of the field. So here, if you look at this trapezium, this AB is perpendicular to these parallel line segments, right? Now, this is 48 meter, that is BC is 48 meter, CD is 17 meter and DA is 40 meter. Now, in order to calculate the area of a trapezium, we have a general formula that goes like this. Area of a trapezium is equal to half multiplied by this height, this perpendicular line segment height, and multiplied by sum of parallel sides. Now this is the formula, this is a general formula to calculate the area of a trapezium. Now here height is what? AB, half multiplied by line segment, the measurement of line segment AB multiplied by the sum of parallel sides, means that BC plus AD. Now we have the values of BC and AD, but we don't have the value of AB. In order to calculate this value of AB, we'll use the length of the fence of a trapezium. Fence means what? The boundary. So the length of the boundary is actually 120 meter. It means that length of AB plus length of BC plus length of CD plus length of DA or AD is equal to 120 meter. We don't know AB, so AB will be equal to 120 meter minus BC plus CD plus DA. So 48 plus 17 is 65 plus 40 is 105. So this is 105 meter. From here you get AB is equal to 15 meter. Now if AB is equal to 15 meter and if you put this value here, this becomes half multiplied by 15 multiplied by BC plus AD means what? 88. So this is 88 meter squared. Now if you solve this, you get, this is 44, and from here if you solve it you get 660 meter squared. So this is the area of this trapezium. Find the area of a rhombus whose side is 5 centimeter and whose altitude is 4.8 centimeter. If one of the diagonals is 8 centimeter long, find the length of the other diagonal. Now in this question, we have a rhombus. Let's name it A, B, C, D. The side of the rhombus is 5 centimeter. It means that every side will be of the same length, that is 5 centimeter, and whose altitude is 4.8 centimeter. Its altitude is 4.8 centimeter. Let's say that from this vertex A, we draw perpendicular on this line segment CD. Okay, so this, let's call it AL. The intersection point is L. So the line segment AL is perpendicular to the line segment CD. It means that AL is the altitude. AL is the altitude in this case. Now, since a rhombus is actually what? A parallelogram. Right? It's a parallelogram. And the area of a parallelogram is given by base multiplied by height. Base multiplied by height. In this case, base is what? CD, and height is what? AL. Right? This is the formula to calculate the area of a parallelogram. But since Rhombus is also a kind of parallelogram, therefore this formula will be applicable to the rhombus as well. Okay, so if you put these values here, CD is 5 centimeter, AL is what? Is again 4.8 centimeter. The value is 4.8 centimeter. If you multiply 5 centimeter and 4.8 centimeter, then the area you get is 5, 8, 44, 5, 4, 20, 24 centimeter squared. So the area of a parallelogram, or in this case rhombus, is 24 centimeter squared. Okay, so its area is 24 centimeter squared. Now the next part of the question is, if one of the diagonals is 8 centimeter long, find the length of the other diagonal. Now it's saying that if you have calculated the area, then can you tell the length of one of the diagonals whose value we don't know? Now since we know the value of one of the diagonals, and the two diagonals are like this, right? Now when we have to calculate the area using the diagonals of a rhombus, we have a formula that says area is equal to half diagonal 1 multiplied by diagonal 2. Okay, we don't know which of these two diagonals has a length of 8 centimeter. We don't know that. Let's say that D1 is 8 centimeter, right? We don't know which of these two diagonals has a length 8 centimeter. So let's say that D1 is equal to 8 centimeter. So from here it becomes half multiplied by 8, and we don't know the value of D2. Just write it here. This is centimeter squared, because we'll take the unit of this D2 as centimeter. So this is the formula, this is the area of the rhombus when we have to use the diagonals. Now whether you calculate area from this formula or from this formula, the area is going to be the same. It's not going to change. So using this value we can calculate D2 now. How? This is half multiplied by 8 multiplied by D2 will be equal to 24 centimeter squared, right? This will be 24 centimeter squared. And why? Because this is the area we have calculated using the altitude and the base, right? Now this is the area we have calculated using the diagonals. These two area will be the same. Now if you calculate from here, your D2 comes as 6 centimeter. Okay. The top surface of a raised platform is in the shape of a regular octagon as shown in the figure. Find the area of the octagonal surface. So this is the octagonal surface, and you have to calculate the area of this whole surface. And the thing is that this is a regular pentagon. Since this is a regular pentagon, therefore if this is 5 meter, each of the sides of this octagon will be of the length 5 meter. This will be 5, this will be 5, this will be 5, this will be 5. Let's name this octagon. Let's say that this is A, B, C, D, E, F, G and H. Okay. Now this width is 11 meter. If this is 11 meter, and if we draw a straight line between these two vertices, then this will also be 11 meter, right? 11 meter, 11 meter. This is 5 meter. It means that this will also be 5 meter. Now, if you look at this figure now, it's actually consisting of two trapezium, this one and this one. So we have two trapeziums. let's say that trapezium 1 is ABCH and trapezium 2 is GD or FEDG. FEDG. And then we have this rectangle. Let's say that this is rectangle HCDG. Okay, the area of a trapezium is given by half. Let's write it here. Is given by half multiplied by the height. So height is 4 meter. If this is 4 meter, this will also be 4 meter because it is a regular octagon. This is also 4 meter. From half, 4 multiplied by the sum of the two parallel sides. So sum of the two parallel sides means in this case, this is 5 meter. 5 plus 11, that is 16 meter. So from here, you get half multiplied by 4 multiplied by 16 meter squared. This gives you 32 meter squared. So the area of this trapezium is 32 meters squared. You have to remember this one. Now next, the area of this trapezium FEDG. Now tell me, this is 5 meter, this is 11 meter, the height is 4 meter. Don't you think it's exactly similar to this one, this trapezium? They are actually similar. So the area will also be the same because this is 5 meter, this is 5 meter, this is 11 meter, this is 11 meter, this height is 4 meter, this height is 4 meter. You are going to get the same value when you put in this formula. Right? Now, the area of this rectangle. So the area of rectangle is what? Length multiplied by breadth. In this case, length is what? 11 meter. And what's the breadth? That is 5 meter. So you get 55 meter squared. So the area of this rectangle is 55 meters squared. Now, the area of this octagon will be this area plus this area plus this area. This trapezium plus this rectangle plus this trapezium. 32 plus 32 is 64 plus 55 is 69 and 119 meters squared. So the area of this octagon is 119 meter squared. Find the area of each section of the frame if the width of each section is the same. Okay. The outer section is actually a rectangle. The inner section is also a rectangle because the length here is 24 and this height or the breadth is 28. This is 16. This is 20. Okay. Now, the question says that the width of each section is the same. So if the width of each section is the same, in this case, the width will be this one. And in this case, the width will be this one. Now, from here to here, from here till here, the length is 28 centimeter. Okay. Now, if this length is 20 centimeter, right? This is 20 centimeter. So if this length is 20 centimeter, then don't you think that this will be 4 centimeter and this will be 4 centimeter? Because 4 plus 20 plus 4 will be 28 centimeter. This is, let's name it, let's call it that it's A, B, C, D, this is E, this is F, this is G, this is H. Okay. Now, the area of, the width is 4 centimeter is 4 centimeter. Now, all the widths of each of these all the sections is actually what? Same. So this will be 4 centimeter. This will also be 4 centimeter. And this will also be 4 centimeter. Okay, now you have to calculate the area of each of these sections. So in order to calculate it, you can clearly see that if you look at this section, this is trapezium, this is trapezium, this is trapezium, and this is trapezium. We have 4 trapeziums. Trapezium 1 is actually ABFE, ABFE, and if you look closely, this trapezium will be actually equal to, or the area will be equal to this trapezium, that is, let's call it T2, that is HGCD. HGCD. And why? Because if this smaller side is 16 centimeter, one of the 2 parallel sides in this case is 16, in this case it's also 16, that is, this is also 16 centimeter. Okay, if the largest side of the 2 parallel sides is 24, here also it's also 24, right? And the height is 4 and the height is 4. It means that this trapezium is exactly the same to this trapezium. Therefore, when you'll calculate the area of this trapezium, the area of HGCD will also be equal to the same, will be same to this one. Now, in order to calculate the area of a trapezium, we know that we have a formula, we have a general formula that says half multiplied by height multiplied by sum of 2 parallel sides. Okay, so half, what's height in this case? 4 centimeter. What's the sum of 2 parallel sides? 24 plus 16 is 40. So this becomes 80 centimeter squared. So the area of this trapezium is 80 centimeter squared. Therefore, the area of this trapezium will also be equal to 80 centimeter squared. Okay. Now, in the same way, the area of the trapezium, let's say that it is T3, AEHD will be equal to the area of the trapezium, let's call it T4, FBCG. Now, the area of this trapezium will be what? If you use this formula, it will be half. What's the height? Height is same, that is 4, multiplied by the sum of 2 parallel sides means what? That is 28 plus 20, that is 48. Right? Centimeter squared. If you solve it, you'll get 96 centimeter squared. So the area of these 2 trapezium will be 96 centimeter squared. So we have calculated the areas of each of these trapeziums.